All right, so the 90, I keep doing 90, 68, 95, 99.7 rule. All right, so we're kind of going to put it all together here and also use the percent regions in the curve. So I've got the picture drawn here, so if you remember the percent regions from the very first page of the note, or for the very second page of the notes. We're going to kind of fill this out, and then I'm going to go answer the questions. I'm going to fill it out first. So we know that so this would be the size of the set. So again, that would be sort of n. N would represent, and typically represents our size. So 200, 2,000 freshmen. All right, mean. So took a big biology test, and again, tests typically, again, especially in a large class, tests typically do land in a normal curve, at least one way or the other, and all standardized tests typically land in a normal curve. All right, so the average for this test, the mean, the median, and the mode were all 70. The standard deviation was 5. And so I'm going to fill this out first. I'm going to kind of hold on to this. This is something I'm going to use in a little bit. So I'm going to fill out my curve. So the average, which is in the middle, the mean, median, and mode was 70. So again, the average of the class was 70. The middlemost value was 70, and the value that occurred the most often was 70. Then I'm going to go up. So these represent my deviation. So this represents the first deviation. So I'm going to add one deviation. My deviation is 5. So this goes up to 75, down to 65. Now I'm going to add two deviations. I'm going to go up by 5s. So this goes up to 80, and this goes down to 60. And then the last deviation, 85, down to 55. And so if you remember from the first picture, this represents the 68%. Right, and so if we split it, and I'm going to split it because I'm going to write it all out. So this would represent the 68%, which means this half is 34%, and this half is 34%. All right, going all the way out here, that's our 95%, which means half of it would be 47 and a half, so half over here would be 47 and a half. I'm going halfway, right? 95 total, halfway. So if I shade in that area here to here, that's my 95. So remember, this was our 13.5, right? If I took 34, subtract it from 47 and a half, this comes out to 13.5%. This also, because of symmetry, comes out 13.5%. All right, then the last one, which I'm going to draw below since I don't have enough room above, that's our 99.7%. So again, half of the 99.7% would land on one side, half of the 99.7% would land on the other side. So if I cut it in half, this half over here would be 49.85. If I took my 97 and divided it in half, this would be 49.85. And so we'd take our 14.5, subtract it from the 49, and so remember this little piece up here, subtraction, is 2.35%. And then the little bits on the edges, right, we have what's left is the 0.3%, so we split half a 0.3% above, half a 0.3% below, and so this little bit of area here and this little bit of area here is 0.157%. Alright, and so those are the percents that we're going to use. Alright, so we're kind of putting it all together to answer the following questions. This is sort of setting up the whole curve with all of the areas using our rule of thumb. Alright, so now I've got it all set up, all the numbers marked off. We'll go to answering the question. So what percentage of scores land between, what percent of the class, or what percent of the freshmen had a score between a 65 and a 75? Well, that's our one standard deviation away. So that was 68% of the freshmen. And so what we're going to do is there's an added question. So that's the percentage. 68% of the class, or 68% of the freshmen, had a score between 65 and 75. Now we want to know, well, how many does that translate to, right? We had a total of 2,000. Out of the 2,000, What percent would have what number, we know the percent, 68, what number would have scored between a 65 and 65 and 75, too many numbers going around. So, between a 65 and a 75. Well, you take your percent and multiply it by the total. And remember, whenever we multiply by the percent, it's the percent as a decimal times the total number. So in this case, the percent as a decimal would be 0.68. You divide by 100 to get the percent as a decimal. And then you'd multiply by the total. Well, there's a total 2,000 freshmen who took the test. 68% of them scored between a 65 and a 75, so you're taking the percent of. And so you take your 2,000 times your 68%, and so that means 1,360 scored between a freshman. Scored between, again, it's the majority of them, right? 68%. Majority of the students, majority of the freshmen, scored between one standard deviation from that mean, that 70% mean. Alright, so 1,300, and if you check your answer, take your 1,360 divide by 2,000, and it should give you your 0.68, or 68%. Alright, now we're going to look at between who scored in the 60 to 70 range. Alright, so 60 to 70 range is this range here. So, let me change my color. 60 to 70 is that distance there. So 60 to 70 is on half of the bottom half. So that's that 47 and a half, right? The 34 plus the 13 and a half, that's half of the 95. And so that's the 47.5% scored between a 60 and a 70, right? That's this group to this group. All right, so you take your 13 and a half, your 34%, and that adds up to 47.5%. All right, now we're going to do the same thing. Well, 47.5, so almost 50%, a little bit less than 50%. How many does that represent? Well, again, we take the percent as a decimal times the total. So you're going to take your 0.475 exactly, don't round, it's exactly 0.475. Multiply it by the total number of students, which is 2,000. And so it comes out 950 freshmen scored between a 60 and 70%. Almost half of them, not quite, a little bit less than half. Alright, what percentage of students scored between a 60 and an 85? So now I'm going to go up to my picture and look at where the range is between a 60 and an 85. So 60 starts here. 85 would go all the way over here. So this should be almost all of them. It's almost the 95% minus this little 2.35. Alright, so I don't have that little 2.35. It's just going 85 to 60. Alright, so the easiest way to figure out that area would be take, well, I know that's almost the 99.7, but minus this little bit. Minus the 2.35. Alright, so that's going to give me out 97.35. Alright, that's what that area is. Between 60 and 85, it represents 97.35% of the freshmen. Alright, so 97.35% of the freshmen scored between a 60 and 85. So now, again, how many? Well, you take that as a decimal. Exactly, so 0.9735, don't round, exactly 0.9735 times our 2,000 freshmen, and that comes out to be, and again, it should be almost all of them, right? 97% is almost all of them, and it is. Out of the 2,000, 1,947 of them scored between a 60 and an 85. Again, should be almost all of them. 97% represents almost all of them. Alright, the next one. How many scored less than 55? So scored less than 55. How many? So I've got to remember how many. So I'm going to find my percent first and then figure out how many. So less than 55. Erase this. Maybe. Alright, so 55 puts me here. And I want to be less than it. Well, that's that 0.15%. So very, very small. This shouldn't be very many students at all. And this should be outliers. Very few students scored less than a 55. That was the 0.15%. So 0.15% is the percentage. When you convert that to the decimal, you're going to take the 0.15% divided by 100%. And so it's going to come out to be 0.0015. That's what you're going to multiply by. So 0.0015 times our 2,000 comes out to be 3 freshmen. Alright, so only 3, and it should be small, right? Check your answer. Take 3, divide by 2,000, it should come out to be 0.15%. Very few of the freshmen scored less than 55%, only 3 of them. So again, it's a small outlier. Alright, how many students, again, I'll figure out how many first. I've got to find the percent, scored above an 80. So I'm going to go look at my picture again. 80 puts me here, so this is the 80. So how many scored above an 80? Well, that would be the 2.35 and the 0.15, so I have to add those up. So 2.5% scored above an 80, so 2.5%. So 2.5%. Remember, you've got to convert that to a decimal. When you convert to a decimal, you take your 2.5% divided by 100%, and it's going to come out 0.025. 0.025 is what you're going to multiply by. So 0.025 times the 2,000. I don't know why I circled it. And again, it should be a small number. 50 freshmen. Remember, it's 50 out of 2,000, so it's a small number of freshmen scored above an 80%. Only 50. And if you check your answer, take the 50 divided by your 2,000 and see if you get the same 2.5%. And you should. Alright, so that's an example. That's the last sort of example, sort of putting it all together with the percents under the normal curve and our standard deviations using our rule of thumb rule. 1 standard deviation, 68% of people land there. 2 standard deviations, 95% land there. 3 standard deviations, 99.7% land there. The next example is, well, what if we don't land exactly a deviation away, right? This is just 1 deviation. What if my score was at a 60 instead of, a nice standard deviation away? What if my score was at say a 62? Right? Well, what percent of the students land at a 62 or fewer? Or a 88 or more? Alright, so when we look at those, we have to do another method. That other method we're going to use is the table method. Alright, we will be using the table method. Alright, I'll pick that up in the next video.